solving radical equations, right? We've done all of kind of the operations on them, like how to add and subtract and multiply and divide. Now we're going to look at it in terms of, if we have an equation, how do we go about solving them? And there are steps, which I know you all like it when there are steps. First step, because it'd be silly to start with the third step, is to isolate the radical to one side of the equation, right? Just like it was a variable, like we were solving for a variable, we'd get x all by itself on one side. The whole idea is to get the radical all by itself on one side of the equal sign. So isolate the radical on to one side of the equation. Number 2, raise each side of the equation to the power of the index. Raise each side of, it looks like a C, of the equation of the to the power of the index, right? So if I have a square root, we're going to raise it to the second power. If we have a cube root, we're going to raise it to the third. If we have a fourth root, we're going to raise it to the fourth power, to the power of the index. What it does when we do that is it removes the radical, right? It gets rid of that radical sign when we raise something to that power. If I have something that's a square root, if I have the square root of x and I square it, I just wind up with x. And so that is the purpose of the second step. The third step would be to solve the remaining equation for the variable, right? The last step is to check for extraneous solutions. And we will go over what extraneous solutions, All an extraneous solution is a solution that doesn't work. So we plug it in. If it doesn't work, that's an extraneous solution. And the rest of this lesson is all just going to be examples of how to do this. Now, this is nothing you haven't done before. It's just we haven't done it in this format, right, where it's radicals, but we've done it with other things. So our first example is if I have the square root of x plus 5 equals 12. If we look at our first step, it says to isolate the radical to one side of the equation. That means the only thing we want on one side of the equal sign is this square root of x, right? Everything else needs to be on the other side. And so I'm going to start by undoing everything that's being done to that radical x. And the only thing in this circumstance that's being done is we have 5 being added to it. So we're going to start by subtracting 5 from each side. And we wind up with the square root of x equals 12 minus 5, which is 7. Right? Step 1's done. We have the radical all by itself on one side. And so the next part says to raise each side of the equation to the power of the index. Well, when we have a radical with no index listed in here, that index is always 2. We just don't write it, right? When it's a square, we just assume it. And so what we're going to do is we're going to go ahead and raise each piece, each side to the second power. What it does is it eliminates that radical sign. And so on this side, we are going to have x equals 7 squared. Well, 7 squared is 49. Seven squared is 49. Okay, so x equals 49. To check for an extraneous solution, we're going to plug in our x value into the original equation and see if it works. So I would have the square root of 49 plus 5 equals 12. Well, the square root of 49 is 7 plus 5 equals 12. So we know we're good, right? Make some sense? So far, nothing too difficult, right? We can all kind of follow this. What if we have, let's do one with a different power. What if we have 3 minus the 4th root of m equals 0? So again, when we look at this problem, we're going to start with, well, what's being done to this 4th root of m? Because we got to get it all by itself. And so I'm going to start by, I have a positive 3. And so I'm going to go, okay, well, we're going to subtract 3 from each side. And we wind up with minus the 4th root of m equals negative 3. Well, negative the 4th root of m is not the same as getting it isolated, right? That negative's still going to have to come out, right? Because that's like saying negative 1 times the 4th root of m. So to get rid of that negative, we could either multiply or divide everything by negative 1. I'm just going to divide because, well, it's easy. And I'm going to wind up now with that 4th root of m equals 3. Now it's positive because we have a negative over a negative. And so now we're at step 2 where we can raise. That's all right, America. Hey, America, are you leaving us? Are you going to another school? So now we have the 4th root of m, right? And so we can start on step 2 where we could go, okay, well, we're going to raise each side of the equation to the power of the index. Well, in this case, the power of the index is 4. So we are going to raise this to the 4th power and this to the 4th power, right? And what that does is it cancels our radical and we're left with m equals 3 to the 4th power. Well, 3 to the 3rd power is 27, so 3 to the 4th power would be 81, and that will be our solution. And we can check it. We can see if we're right, so see if we have any extraneous solutions, right? We have 3 minus the 4th root of 81 should equal 0, and I know that the 4th root of 80, that would be 3 minus 3 equals 0, so we are good, right? That's a true statement. That's all right, America. America, are you leaving? Are you going to another school?
Tomorrow, I think I'm going to start the enrollment to go to Alessandro.
Oh, okay. I got an email for your exit grades. I'm like, no, she's leaving. Well, good luck to you there. Let's see what else we got. Ooh, I like this one. Here's a good one for us. What happens when I've got multiple things underneath that radical? Say I have 6w minus 5. That's a 5, not an S. I know it kind of looks a little S-like. It's a 5. And then not under the radical, we'll say plus 10, and we'll have it equal to 3. First thing we want to do is get rid of this 10, right? We're going to move it over. We're going to subtract 10. And then I'm going to go 6w minus 5 equals negative 10. Now, I can already tell you just by looking at this that we're going to have an extraneous solution. We're going to have a solution that doesn't fit. And the reason I know that is I have a square root equal to something that's negative, right? And that can't really happen and still be true. So I could look at this right now and see, look, my radical, right, is already set to something negative, and I know that that can't be true because it could be true if it was like a third power or a fifth power or seventh power, if it was an odd power, but I have an even power, right? This is technically an index of 2, even though it's not written because we don't write the 2. And it is set equal to something negative. So I can tell you right now that there isn't no solution there. Well, the thing is if I have negative 7 times negative 7, that negative 7 is 49. Like when we square it all, it's not going to stay a negative. Remember, if it's a even root, like if our index is even, anything that is negative would have to come out as an imaginary number. And so we can't have it set equal to a negative. And we could look at that right away. Once we isolated it and it was equal to a negative, we could go no solution. But if we worked it out, we would have to put it in there and realize that it's no solution once we solved it out, right? But the easiest way to tell when there's something that has no solution is that you have an even indexed thing set to a negative. It'll save you a ton of work just to remember it that way, that once you get it isolated, if it's set to a negative, you could automatically just write no solution. Or you could do all the work on it, and then when you check for extraneous solutions, you could see that that would be extraneous. But that's a lot more steps for you, right? Now, they won't all, when they're all set up like this, they're not all going to have extraneous solutions. Sometimes you'll have something like if I have 10 plus the square root of r plus 7 equals 11, right? We're going to go ahead and subtract 10 from both sides so that we're left with the square root of r plus 7 equals 1. So we have multiple things under here, but we can still go ahead and square both sides, right? Our index technically is 2 here, even though we don't write it. So I'm going to raise that to the second power and that to the second power. And I will wind up with r plus 7 equals 1, because 1 squared is just 1. And then we'll just subtract 7 from both sides, and we get r equals negative 6. Sometimes you will get it in terms of in exponential form instead of radical form, but it still works the same way. If I have say I have like 7p minus 1 to the 1/3 power plus 11 equals negative 7, right? We're going to still isolate this whole piece because, yeah, you know how we can write them back and forth like we did in that last assignment. Just raising it to the 1/3 power still means it's the cube root of that. But all we'd have to do is we move the 11 over by subtracting 11. And here I'm going to go, okay, well, I've got 7p minus 1 to the 1/3 power equals negative 18. This is a 1/3 power, so we can have it equal to a negative. That's okay, because that's an odd number power. And what we're going to do is we're going to take this whole thing and we're going to multiply it by the denominator, because the denominator is that index, right? So we're going to multiply this times 3 to the third power and this to the third power. I don't even want to know what this is to the third power. Did I do something wrong there? Oh yeah, this was supposed to be positive 7 right here. I was looking at two different problems. My apologies on that. So this is 7, now minus 11, which is just negative 4, which makes our lives easier because 18 to the third power is a lot. And so what happens when we raise this to the third power, all of this stuff goes away, right? And we're just left with 7p minus 1 equals 4 to the third power. Now 4 times 4 is 16 times 4 is 64. Now this is negative, right? This is negative 4. So we have negative 4 times negative 4 is positive 16 times another negative 4 is negative 64. And so now we can just solve this whole thing for p. If you don't know how to do 4 to the third power in your head, do it on a calculator, right? There's nothing wrong with that. So we're going to add 1 to both sides, and we're just going to work to get this p all by itself, which sounds kind of funny, which is negative 63. Then our last thing, the only thing left being done to that p is that we've got 7 being multiplied to it. So I'm going to go ahead and divide both sides by 7. And I wind up with p equals negative 9. And that's pretty much it. The only other thing I can think of is if you have a square root on both sides, or you have a radical on both sides. Like if I have v minus 8 equals 43 minus 2v, right? And they're both underneath radicals like that. Just square both sides. Or if they were cube roots, cube both sides. But in this case, they're squares. So you would just square this and square this, and then both sides come out of the radical, right? And so you're left with 43 minus 2v. And then you could just solve both sides for v, right? We could go, well, let's add 2v to each side. And here we're going to get 3v minus 8 equals 43. And then we're just going to keep going until we get v all by itself, right? Plus 8 plus 8, and we get 3v equals 51. And then we can divide by 3. And we get v equals 17. But so if you see something where you have square roots on both sides, that's all you have to do, just square both sides. That's pretty much as complex as it's going to get for you. Your whole assignment is in Delta Math, so you really don't have to show me the work. And then when you come back on Thursday, it'll just be a quick check-in so I can get you down for attendance. And then if you don't have any questions, I will let you go, but there won't be a new assignment on Thursday so that you don't have to have homework going into your week off. Any questions about any of this?